Hello, my Calc 2 students. Today we talk about series and convergency. It's section 9.2 in your book. And this is absolutely new object, what we're not working before. And here remember, sometimes we use this symbol where you have integration, sigma, and changing from 1 to infinity, an. What does mean this symbol? It means you adding a first, a second, a third, and continue the ends and all other numbers, because here is n changing from index your term changing from 1 to infinity. Sequence partial sum. Sequence. Oops, sorry. I think it's this way will be better. Okay. Sequence partial sum. It will be this kind of. As first, it's first term. As second, and first, sum first, it's second term in the year series. As ends, it will be sum first and terms. And because we have sequence, we have question about this sequence is convergent or divergent. And now we have definition who tell us definition. For infinity series an, where is n changing from 1 to infinity, the partial sum, this. Oh no. Sums. Sum is Sn 1 a2 plus an. And we have this kind of, if sequence is partial sum Sn converges to some S, then infinity series converges to, and this sum is equal S. If sequence partial sum diverges, this means series, infinity series is diverges. Thinking some type of infinity series maybe we used before. First one is called geometric series. Geometric series. It's series one you can rewrite for this shape. Where's n from 0 to infinity? This means, what does mean here? First term is will be a. Second term is will be a times r. Third term is will be a times r squared. and then it's continue. And now we have some theorem tell us if absolute value, your ratio R, this is R calls ratio, and A is first term, are greatest or equal 1, absolute value R. Then geometric series diverges. If your ratio R absolute value less than 1, then geometric series converges. Okay, try prove this fact and same time found formula that tell us the series, sum this geometric series equal A over 1 minus R. Okay, proof. Let's go Sn. Partial sum is mean you add n first terms. This means here we have A plus AR plus container plus AR to the n. Well, here is n start with 0, this means n plus 1 terms. It's no problem. Now I multiplied this sum for R. Rsn will be AR plus AR square R n plus 1. Subtract from first equation second, we have Sn minus R times Sn. But looking here, if you subtract right part, your equation, all terms is cancelled except first one and last one. And this means Sn will be A 1 minus R times 1 minus R n plus 1. Okay. Well, here we're thinking R is not equal 1. Okay, great. What is will be limit Sn? Limit Sn if n approach to infinity. It will be limit A1 minus R n approach to infinity 1 minus R n plus 1 power. This part not depend n. This means only we are looking what happened with our inside parentheses. If R, absolute value R, less than 1, then limit R n plus 1 power and approach to infinity will be 0. If absolute value R greater than 1, you have this limit not exist. Or series is converges, or this not series sequence is converges. Okay, and this means we need only checking what happened if r equal 1. Then your series Sn will be so we have a plus a plus a and continue. This means n times a. Limit n times a and approach to infinity not exist. The C diverges. This means we're proving our theorem. Okay. Doing some example. I have series and start with 0 to infinity, 5 over 3 to the power n. The series is converges because first term here is equal 5 and ratio equal 1 over 3. This means the series is converges and sum equal 5 divided by 1 minus 1/3. 2/3, I think it's 15 halves, 7.5. Okay. Example B. What happened if I have 5/3 to the power n and start with 0 to infinity? For n equals 0, we have 5/3 0 power. This means a equal 1. Ratio here is 5/3, who is greatest than 1. This means this series is diverges. And number C, n from 0 to infinity, 3/5 to the power n. What we have here? A equal 1, r equal 3/5. This means here we have 3/5 is less than 1, and absolute value 3/5 is exactly 3/5. This means here we have 1 over 1 minus 3/5, 2/5, 5 halves, 2.5. Okay, great. One more type of series one we study now is telescoping series. Telescoping series. If you're serious, this type, when you can rewrite, here's n start with 0 or n start with 1. Okay, let's go, it's 1. It's no big problem. It depends what kind of example you have. If you can rewrite your series like this way, where you have b1 minus b2 plus b2 minus b3 plus, and this is continue, then this kind of series we call telescopic series. And looking here, this means partial sum this series is first term minus n plus 1 terms. This means limit Sn for n approach to infinity, it will be limit first minus bn plus 1 n approach to infinity, or b1 minus limit and plus 1 terms. And now series is converges or diverges, all depend what happened with n terms this series. If n terms approach the 0, series is converge. If terms is approach to something. If it's not approach to some number or diverges, this means the series is diverges. Okay, looking examples. Example. Let's go, we have series is 1 over n minus 1 over n plus 1, whereas n change from 1 to infinity. You can see easy, this is n equal 1, you have 1 minus 1 half, plus n equal 2, you have 1 half minus 1 third. And then you continue, you have something similar. This means our Sn is 1 minus 1 over n plus 1. If you take it limits here, the limit Sn, and approach the infinities will be limit 1 minus 1 over n plus 1, and approach the infinity. And this limit is equal 1. This means our telescopic series is converge and sum equal 1. Making one more example, and let's go example B. When you have series is 2 over 4n squared minus 1. But this series is telescopic series too, and now I show you how we can work. Here we use method to rewrite this fraction like partial fraction. This means 4n squared minus 1, we can factor in like 2n minus 1, 2n plus 1. Okay, this means I have one fraction, whereas I have denominator 2n minus 1, plus second fraction when I have denominator 2n plus 1. Go back, make it same denominator, and we have coefficient n will be 2a plus 2b. But our first fraction in numerical doesn't have any n. This means here we have 0. Constant, we have a minus b and equal 2. Now solving this system, I think it's first we cancel 2 here, and then we add two equations. We have 2a equal 2. This means a equal 1 and b equal negative 1. Now our series is 2 over 4r squared minus 1, and start with 1 to infinity is series when we have a is numerical 2n minus 1. This means 1 over 2n minus 1 minus 1 over 2n plus 1, and from 1 to infinity. If you rewrite, you have n equal 1, you have 1 minus 1 third. N equal 2, you have plus 1 third minus 1 fifth plus 1 fifth minus 1 seventh, and continue. This means this sum is equal 1. Okay. Continue work with series. Now I want to write property of infinity series. Let's we have two series, and both of series is convergence, and from 1 to infinity a n series sum is a, and series b n, and start with 1 to infinity, it will be b. Then we have this kind of property. First one, if you multiplied each term your series with same constant, this means sum the series, it will be multiplied by same constant. Okay, and second one, if you add or subtract corresponding term to series, then it means you add or subtract sum. And now we have very important theorem. Theorem tell us if your series is converges, if here we always talk about infinity series, converges, then limit a n approach to infinity equal 0. What does mean? This means if your series is converges, this means n terms your series approach to 0. Please be careful. This theorem work only one way. This means converges series and terms is approach to 0. Opposite is not right. Okay. And future I show you a lot of examples whereas opposite is not right. Okay, let's proving this theorem. Let's well, let's an series an from 1 to infinity is converges. This means sum is equal limit partial sum and equal some number a, real number a. What if have Sn plus first terms? It will be Sn plus one more term, next term. Okay, and because limit Sn plus 1 and approach to infinity equal limit Sn and approach to infinity, and both of this limit is equal a, we have limit a n plus 1 and approach to infinity equal limit Sn plus 1 minus limit Sn and because it's a minus a, it will be 0. This means we're proving limit a n and approach to infinity equals 0. We proved this fact. And now we have first test about convergence or divergence our series. This time I think it's more than 10 theorems you need to remember, but this is first one. Practically second one, because first one was about convergence geometric series. This is test about n-term test for divergence. N-term test for divergence. And this test tells us if limit n terms is non-zero, then your series diverges. This is only rewriting theorem what we proved now. This means if series is convergence, then n terms approach to zero. If n terms not approach to zero, this means series is divergence. Okay, looking for examples. A series where you have 5 halves power n, and from 0 to infinity. Well, here you can say it's geometric series. It's geometric series, and we now ratio here is 5 halves. This means series is diverges. But we can use this test to limit 5 halves to the power n and approach to infinity. Because base is greater than 1, this means if power approach to infinity, here we have infinity, and series is diverges. Okay, looking one more example. This first one you can solve in two different ways, but what about second one? We have series here is n factorial over twice n factorial plus 1, and start with 1 to infinity. Okay, this is not geometric series, this is not telescopic series, this means we need only use this fact. Okay, limit n factorial over 2 n factorial plus 1 and approach to infinity. Oh, easy way, I think it's divide by n factorial. We have divide up and down for n factorial, 1 over 2 plus 1 over n factorial. And this limit is 1/2. Limit is non-zero, and this means our series is diverges. And last question, last example. See, we have series where we have 1 over n and start with 1 to infinity. Limit 1 over n and approach to infinity. Here we have 1 over infinity, this means 0. But because it's 0, we don't have answer. We don't know the series converges or diverges. It means our test not working. In the future, when we have more tests, we can use different tests. But right now, we don't have any answers. Okay? Then couple of examples in from your book which help you solving homework. Number 8. Here we have series and start with 0 to infinity 4 times negative 1.05 power n. This is geometric series which first term is 4 and ratio is negative 1.05. Absolute value r, it will be 1.05. It's greater than 1. This means series is diverges. Okay. Second example. Number 12. Here we have series and start with 1 to infinity n over square root n square plus 1. Here we try use our n-term test. What is limit n over square root n square plus 1? And approach to infinity. Here I think it's up and down, we divide by n. And what we have there? We have 1 over square root 1 plus 1 over n square. And divide by n, this means inside root it's got like n square. And this limit is 1, is non-zero. This means series is diverges. Okay. More example. Number 16. Here we have series and start with 1 or 0. I think it's 0. 2 times negative 1/2 power n. Okay. Here is geometric series with first term is 2. Ratio is negative 1/2. Use formula because absolute value r equal 1/2 less than 1. This means converges. And this means our series is first term divided by 1 minus r plus 1/2. It will be 4/3. Okay. Number 20. Here we have series and from 1 to infinity 1 over n times n plus 2. Okay, great. Now we need, looks like we have telescopic series. This means we need to rewrite like combination partial fraction. 1 over n times n plus 2. It will be a over n plus b over n plus 2. Try doing same denominator. And now I have coefficient for n, it will be a plus b. And because we don't have any n in numerical, our fraction, this means this is 0. Coefficient constant is we have only 2a, and 2a equal 1. We have a equal 1/2, b equal negative 1. This means my series, I write that this is like star and move to there, equal. I can rewrite this way. It will be 1/2 out and 1 over n minus 1 over n plus 2. Whereas n change from 1 to infinity. Because 1/2 is for each terms, this means we can write 1/2. And this we have 1 minus 1/3. Okay, plus 1/2 minus 1/4 plus 1/3 minus 1/5, okay, plus 1/4 minus 1/6, and then continue. This means what we have here: 1/3 cancel it, 1/4 cancel it. I'm absolutely sure 1/5 and 1/6 cancel it, and you have only two terms who stay, 1 and 1/2. This means you have, or we have 1/2 times 3/2. It will be 3/4, because 1 plus 1/2 is 3/2 and multiplied by. Okay. One more example. Number 30. Here you have 9 minus 3 plus 1 minus 1/3 plus, and continue. Looks like we have a geometric series which first term is 9 and ratio is negative 1/3. Ratio is negative because every time you have change in sign. Minus, plus, minus, plus. As happened if you multiplied for negative number every time. Okay. Absolute value negative 1/3 less than 1 because it's equal 1/3. This means this series is convergence, and we can write what the sum is. The sum is, okay, equal, move to here. First term is 9 over 1 minus negative 1/3. This means 9, 1 plus 1/3. 4, I think it's 27 over 4. Number 34. I'm trying to show you more example because infinity series is absolutely new object for you, and you can be more familiar and see it's nothing scary. Okay, what we have here: 1 over 9n squared plus 3n minus 2. Here we need found sum. This series looks like this is telescopic series. Okay, what this will be? 1 over, first I can try factoring. It will be 3n plus 2 and 3n minus 1. This means here we have a over 3n plus 2, b over 3n minus 1. You see, we're always doing something very similar. Try make it same denominator. This means multiplied by different denominator. Coefficient n will be 3a plus 3b and equals 0. And minus a plus 2b, it will be 1. Well, I think first you can easy cancel 3 and add this to equation. You have no a, but you have 3b equal 1. This means b equal 1/3. It means a equal negative 1/3. Okay. And this means our series is 9n squared plus 3n minus 2, and from 1 to infinity this will be 1/3. Series is 1 over 3n minus 1 minus 1 over 3n plus 2. and start with 1 to infinity, and we try write what is it. It's 1/3. Here we have n equal 1. This means 1/2 minus 1/5. N equal 2, it will be plus 1/5 minus 1/8 plus 1/8 minus 1/11, and continue. This means all cancel it except 1/2, and our answer is will be 1/3 times 1/2. It will be 1/6. Okay, doing something a little bit different. For example, number 50. We have series ln 1/n, and from 1 to infinity. Okay. If you don't have anything, try n-term test. This means limit natural log 1/n and approach to infinity. What does mean natural log? Limit 1 to n, where's n approach to infinity. Now what this limit is? 0. Now what is natural log from 0? If you're looking for a graph, it will be approach the negative infinity. This means here we have negative infinity. If your n terms limit is non-zero, this means series diverges. Okay. One more example, number 52. Series n from 1 to infinity e to the minus n power. This means first term here, if n equal 1, it will be e to the negative first or 1/e. Ratio every time you multiply by 1/e. 1/e is less than 1. It's positive number less than 1. Okay, this means our series is converges, and we have 1/e, 1 minus 1/e, or simplifying, you have 1/e minus 1. Now I think this last example for this section is section 54, question 54. And start with 1 to infinity, natural log n plus 1/n. Okay, what we have here? We have use logarithmic identity, and you have series n from 1 to infinity, natural log n plus 1 minus natural log n. Okay, what we have here? We have series and start with. Oh, I think we don't need series symbol anymore. We're plugging what we have here. N equal 1, you have ln 2 minus ln 1 plus ln 3 minus ln 2 plus ln 4 minus ln 3, and continue. And I think we have 0 here because we have ln 1 who is 0. That's it for today.